Okay. Question 2. To cope with drought conditions, California requires new shower heads to use 1 and 8/10 gallons per minute. And that's actually the maximum. That means that a 10-minute shower will use 18 gallons of water. So it's actually gives us 2 spots in the table right off the bat. 1 and 8/10 gallons per minute, and then 10 minutes will use 18 gallons. And that 1 and 8/10 gallons per minute is the same unit rate. We're saying that this is a proportional situation, so our unit rate is the same all throughout. Go ahead and pause it and see if you can write that first multiplication equation. Or if you like, you can write all of them. Okay, so we have, just like in our last one, we have a unit rate, and we know that this is a proportional situation, so it is going to be multiplication only. We've got if we've got a 1 minute shower, we're going to use the rate of gallons per 1 minute. Per 1 minute. It won't always say per 1 minute, but if it says per minute, they're talking about 1. So the number of gallons, here we see number of gallons per minute times the number of minutes is the total used. And that makes sense to us. If something is happening in 1 minute, then after 2 minutes, it's going to be twice as much, 3 minutes, 3 times as much, 10 minutes, 10 times as much. So 18 is 10 times 1 and 8/10. So we've got that first equation written. We've got 1 and 8/10 is equal to 1 times 1 and 8/10. And we can even do the same thing we did last time and switch over to that, say this times that equals this. And you may notice that I think in one of the previous worksheets that I gave you, I'd had this X and Y over here, and then I had the unit rate over there. And the reason that I changed this was to hopefully make this pattern make more sense to you so that we can write multiplication equation for each spot in the table and then make that jump to the algebraic equation. Go ahead and try the next 3 and then we'll do the algebraic one separately. And I assume you paused it, you worked on it, you tried, maybe you got it, maybe you didn't. It's the same thing that we saw in the one before, and it tells us here the number of gallons per minute times the number of minutes is the total amount used. I'm just going to go ahead and get rid of these. Okay, so we can write down that our unit rate, the amount per minute, times the number of minutes is the total used. Amount per minute is 1 and 8/10. Multiply that by 10, we get 18. Amount per minute, 1 and 8/10. If we do it for 15 minutes, I guess I should have told you to grab a calculator. Hopefully you use the one on Chromebooks. That's going to equal 27 though, isn't it? Because we know that we've got 18 and then we're going to have for 10 and then another half of that for the other 5. 9 more is going to be 27. Last one, 1 1 8/10 gallons per minute. 20 minutes, that's twice as long as a 10-minute shower, so I'm going to use twice as much water. So we can just essentially duplicate our work over here. Oh, you know what? I just noticed I did something. Maybe you noticed it well before I did. My structure of this one is wrong. It's a good thing we did this thing on the left here. 1 8/10 times 1 is equal to 1 8/10. That equation was valid, but it's a different structure than the one I have on the left. 1 8/10 times 10. I'm just moving that decimal point over. So I have 18. 1 8/10 times 15 is equal to 27. 1 8/10 times 20 is 36. And if I want to be a little bit more precise about how I'm writing this, and you should be in the habit of doing this as well, 1 8/10 gallons per minute times 20 minutes is equal to 36 gallons. When you get into chemistry and physics classes in high school and in college, this will help you understand your problems and answers if you carry through the units. And it will also help you after you complete a problem to understand whether you have an answer that makes sense. Because if we got an answer that said minutes, that wouldn't make sense for the total water use. So again, we're going to try to continue that pattern and try to write that multiplication equation using x as the length of the shower in minutes and y as the total water use in gallons. And I will wait. Pause it. Okay, and I'm just going to do my same thing here. Maybe you did this already. You just wrote a little bit. Multiply here, equal there. And that's great if you did that. But please don't do that if you don't understand why that's happening. Ask a question. 1 8/10 times, or 1 8/10 times x is equal to y. Or you could say the unit rate times the length of the shower in minutes is equal to the total water use. And that makes sense physically, I think, that if you're using 1 8/10 in 1 minute, then if you are using the shower for 2 minutes, it's 1 8/10 and 1 8/10. And multiplication is repeated addition. So we'll carry that over here. 1 8/10 x, 1 8/10 times x is equal to y. Notice I don't use this multiplication symbol here because otherwise it would look like xx, which could be perceived by somebody as x squared or x times x. Get rid of that there. Sorry, I put that down. So we want to read this. We can read this across the bottom as 1 8/10 x is equal to y. Or we can read that as our unit rate times the length of the shower is equal to the total water use. And I've got a little note here. This example assumes proportionality to make an approximation. And you'll find that. That is often the case. Um, for instance, if you have the shower turned on low, you may use a little bit less, um, but that this whole thing here makes it a lot easier to think about a situation. And you'll learn way, way, way later how to do something if our water use is actually something variable.